One full year has passed without a launch. For many observers, this led to the belief that Falcon Heavy had reached the end of its operational life. However, Falcon Heavy is set to make a strong return this year with multiple missions on the manifest. Among them is a particularly significant flight, the launch of a multi-billion-dollar space telescope for NASA. So why does this mission matter? And how will it shape the future of Falcon Heavy after it flies? Let's explore those questions in today's episode of Great SpaceX. Once again, we have to look back at the state of SpaceX in 2025. Nearly every major system in the company's portfolio showed visible progress during that year. Starship continued advancing through development and testing. Falcon 9 maintained its dominant launch cadence and pushed reusability to new heights. Dragon remained a stable and trusted workhorse for both cargo and crew missions. Yet amid all of this activity, one vehicle stood noticeably still. Falcon Heavy did not fly at all. At first glance, this absence is striking. Falcon Heavy debuted in spectacular fashion in 2018, immediately capturing global attention with its triple booster configuration and its ability to lift payloads far beyond the reach of Falcon 9. In the years that followed, its flight rate gradually increased. By 2023, Falcon Heavy reached a peak of 5 launches in a single year, a respectable number for a heavy lift vehicle with a relatively specialized mission profile. However, that momentum slowed soon afterward. In 2024, Falcon Heavy flew only twice. Then, in 2025, it didn't launch a single time. By any simple metric, this looks like a decline. The explanation, however, is neither surprising nor particularly alarming when viewed in context. Falcon 9 offers extraordinary flexibility, high launch cadence, and unmatched reusability. At the same time, Starship is being developed to deliver unprecedented payload mass, full reusability, and radically lower costs once it becomes operational. Between these two systems, Falcon Heavy occupies a middle ground. It's more capable than Falcon 9, but far less revolutionary than Starship. As a result, it can appear as though Falcon Heavy is slowly losing its relevance. Yet this conclusion overlooks a critical reality. Falcon Heavy was never designed to compete on flight rate. It exists to perform specific missions that demand high energy trajectories, large payload mass, or direct insertion into demanding orbits. When those missions aren't ready, Falcon Heavy simply waits. That waiting period does not signal retirement. Instead, it signals a build-up toward a future phase where its unique capabilities will once again be indispensable. Looking ahead, Falcon Heavy is positioned for a powerful resurgence in the second half of this decade. The turning point begins in 2026, a year that's set to mark the rocket's return to flight and a renewed period of operational relevance. The centerpiece of that year will be the launch of NASA's Nancy Grace Roman Space Telescope, a mission valued at approximately $4.3 billion US. NASA awarded the launch contract to SpaceX in 2022 for a price of $255 million, entrusting Falcon Heavy with one of its most important astrophysics missions of the decade. Originally, the Roman Space Telescope was expected to launch in May of 2027. However, recent developments have significantly accelerated that timeline. In early December of 2025, NASA announced that construction of the telescope had been completed. Final integration concluded on November 25th at NASA's Goddard Space Flight Center, marking a major milestone after years of development. Following integration, the mission entered its final testing phase. According to Julie McEnery, the Roman mission's senior project scientist, vibration and acoustic testing were scheduled to begin as early as February. This testing campaign is designed to evaluate the telescope's performance under conditions that closely simulate the stresses of launch and the harsh environment of space. Engineers will verify structural integrity, instrument stability, and overall survivability, ensuring that the observatory can operate exactly as intended once deployed. If these tests proceed smoothly, the plan calls for the telescope to be transported to Florida in June. There, it'll be integrated with Falcon Heavy and undergo final combined testing and launch preparations. Based on this accelerated progress, NASA is now targeting a launch window in the fall of 2026, with September 28th emerging as the most likely date. This would place the Roman launch after the Griffin 1 mission, which is currently expected to fly in July. This revised schedule carries significant implications for both NASA and SpaceX. For NASA, launching Roman in 2026 would demonstrate that the agency can still deliver major scientific missions on schedule and within budget. This point carries added weight given the political environment surrounding NASA's science programs. President Trump's proposed budget cuts raised concerns about the future of several flagship science missions, including Roman. Completing the telescope without cost overruns or major delays sends a strong signal about NASA's ability to manage complex projects effectively. McEnery has emphasized this achievement with confidence. She stated that no compromises were made during development and that the mission meets or exceeds all scientific requirements established during the mission confirmation review. In her words, the telescope that was planned is the telescope that was built. She concluded by noting that the project is truly at the finish line and ready to move forward into launch and operations. For Falcon Heavy, the Roman Space Telescope launch represents something equally important. Alongside the Griffin 1 mission, it'll mark the rocket's return to flight after more than a year and a half of inactivity. The last Falcon Heavy mission took place in October of 2024, making this return a long-awaited moment for the vehicle and its supporters. More broadly, the Roman mission contributes to what could be one of the most active years Falcon Heavy has ever seen. In addition to Roman and Griffin 1, there are at least 3 other missions currently associated with Falcon Heavy in 2026. These include Griffin 2, USSF 70, and 75. Whether all of these missions will actually launch within the year remains uncertain, as their schedules depend heavily on payload readiness and integration timelines. Griffin 2, in particular, remains subject to the progress of its payload manufacturer. Military and government missions remain the primary source of funding and demand for Falcon Heavy. In the coming years, SpaceX is expected to accelerate its efforts to complete missions awarded under Phase 2 of the National Security Space Launch Contract. Looking further ahead to Phase 3, which includes both Lane 1 and Lane 2 missions, SpaceX currently holds the largest share of awarded missions among participating contractors. Many of these missions involve complex orbital requirements and high-energy trajectories that are not feasible with Falcon 9 alone. Until Starship can demonstrate the operational stability and reliability required for launch certification, Falcon Heavy remains the essential vehicle for these tasks. Beyond national security launches, Falcon Heavy is also critical for several ambitious deep space missions. These include NASA's Dragonfly mission to Titan, potential launches of Lunar Gateway modules, and the Dragon XL cargo vehicle. Each of these missions demands a combination of payload mass and trajectory energy that places them squarely within Falcon Heavy's performance envelope. These missions are notable not only for their technical difficulty, but also for their value. Many involve payloads worth hundreds of millions or even billions of dollars. They support national security objectives, scientific exploration, and humanity's long-term presence beyond low Earth orbit. When the stakes are this high, reliability becomes paramount, and Falcon Heavy offers a proven solution. For these reasons, the narrative that Falcon Heavy is in decline does not hold up under closer examination. Instead, the rocket is entering a quieter phase that precedes a renewed period of importance. As the latter half of the decade unfolds, Falcon Heavy is positioned to play a meaningful and visible role in SpaceX's overall strategy and in the broader aerospace industry. This context also helps explain SpaceX's broader fleet strategy. Falcon 9 remains the most active rocket in the world. Reusability is central to this success. With support from both ground-based landing zones and autonomous drone ships, Falcon 9 boosters routinely return and fly again. This capability reduces costs, shortens turnaround times, and enables a launch tempo that no other provider has matched. Looking toward the future, Starship represents SpaceX's most ambitious project. While it remains under development, its potential is unmatched. Once it achieves operational maturity, Starship's size, payload capacity, rapid reusability, and flexibility will redefine access to space. However, until it reaches that point and secures full certification, SpaceX must rely on its existing fleet to meet customer needs. Within SpaceX's fleet, Falcon Heavy fills a specialized but vital role. It flies infrequently by design, reserved for missions that exceed Falcon 9's capabilities. When maximum performance and reliability are required, Falcon Heavy is ready. The mission it will soon support, the Roman Space Telescope, ranks among the most ambitious scientific efforts of the decade. Roman will operate near the Sun-Earth L2 point, roughly 1 million miles from Earth, alongside the James Webb Space Telescope. From this vantage, it will conduct wide-field surveys of the universe with unprecedented efficiency. Roman's 2.4-meter primary mirror Observer matches Hubble's in size but serves a different purpose. Rather than deep, narrow observations, Roman is optimized for sweeping surveys. Its field of view is vastly larger than Hubble's at similar resolution, allowing it to rapidly scan enormous regions of the sky. The observatory carries two core instruments: the Wide Field Instrument, an advanced infrared camera of imaging vast cosmic expanse in a single frame, and a next-generation coronagraph designed to directly image exoplanets by suppressing starlight. Together, they will map large-scale cosmic structure, probe dark energy and dark matter, detect isolated black holes through microlensing, and identify tens of thousands of distant exoplanets. NASA expects Roman, in its first 5 years, to reveal more than 100,000 distant worlds, hundreds of millions of stars, and billions of galaxies, delivering rapid and transformative insight into the structure and evolution of the universe. Much of this discovery will come from detecting over 100,000 exoplanets through gravitational microlensing, where massive foreground objects briefly magnify distant starlight. McHenry has described the mission as standing on the edge of unfathomable discovery, with extraordinary returns expected soon after launch. Although designed for a 5-year primary mission, Roman is likely to operate far longer. Over its lifetime, it is expected to observe billions of galaxies and hundreds of billions of stars, providing critical data on cosmic expansion and dark energy. In this sense, Roman will become humanity's next great eye on the universe, opening new frontiers and paving the way for future missions and eventual human exploration. Soon, a multi-billion-dollar space telescope built to expand human knowledge will launch atop one of the most powerful and reliable rockets ever flown. Falcon Heavy is a fitting vehicle for this mission. This will not be a routine launch. It marks the long-awaited activation of a major NASA observatory and a turning point for Falcon Heavy, signaling its return to flight and a renewed phase of relevance. As the decade progresses, Falcon Heavy's quiet period will give way to renewed purpose. Its partnership with NASA on the Roman Space Telescope makes clear that the rocket's story is far from over. In any case, folks, this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.